Hi, Olivier here. Thanks for watching. Today we are taking a look at Particle. Particle has been around for some time. They made some noise recently with a new series, a system on modules, the M series with multiple network support. What I want to do today is give you that first look at what Particle is about when it comes to developing a little device and what are the few advantages that you can consider or should consider when it comes to developing hardware for IoT solutions. So Particle is an IoT platform as a service. So you get some solution, which is almost turnkey to develop code, firmware for your devices, hook them up to some sensors and different kind of peripherals, and then remotely monitor data from the cloud, the Particle cloud in that case, allowing you to have remote monitoring functionality as well as remote control and authentication and integration into your business applications from the cloud and so forth. Lots of things going on. I wrote an entire article about that, so I invite you to go check it out. The link down there in the description. In the meantime, we want to have this first look at Particle. The first thing you're going to do is certainly go to the website, and definitely invite you to navigate the website. It teaches you a lot about what the platform is about, what kind of devices to expect. What I wanted to highlight over here is jump directly into the notion of system on modules. Well, we'll see the platform aspects as well during this demo, but what I want to show you is this notion of system on module. The idea of the system on module is the packaging of a set of components that will implement functionality in a way that is standardized across different devices. You pick a system on module, it will have a microcontroller in there, it will have a flash memory, it will have a communication modem for cellular, for something else. And this functionality is all integrated. What you need to develop beyond that is a carrier board, something to host this module, and that will be a production grade type of thing. With your own sensors, with your own hardware, and integrate this module. And this way you don't have to care about the core functionality of the IoT device, which is similar across different types of devices, right? Connectivity is similar across devices. Interaction with hardware is similar as well. What's specific to your device is the types of sensors you're using, right? So it basically streamlines your hardware development by skipping the line, going directly to the integration part without having to pick the microcontroller and pick the right modem for you and negotiate the prices and blah blah blah, right? If you look at the website, you'll see there is different series, the M series, the B series, the P2. So once again, I will just invite you to go there. Interestingly, the website leads directly to their store. And there's one thing to notice in here of importance is that you will get access to buying some system on modules by the unit. You also eventually can access evaluation boards to learn how to use Particle in general. You have breakout boards that allow you to go beyond just evaluation, but prototyping your own device. And last but not least, you can access trays of the modules, of the system on modules you want by 50, right? So you can go from that level of prototyping to a higher level, almost production, if not production, directly from the store. That's very interesting, right? To illustrate this notion of system on modules, that's something you're not super familiar with, let me actually bring this little guy here. This is one of the latest system on modules. That's the M635. It is a very interesting one. So you'd say, hey, it's pretty expensive for a system on module, for a chip. Actually, yes, but no. When you consider everything it embeds, it's not that expensive. Let me explain. If you look at the data sheet for this little guy here, first of all, it has a standard connector that allows you to hook it up to a carrier board and eventually switch module. You can do the development with one particular one and then decide to go to production with another one, or you can decide that there's a new version that came out and you want to replace it to add a new type of connectivity, for example, right? You have a product that has Wi-Fi only, and then you have another version of that hardware that needs to have LoRaWAN connectivity. Well, you can just like add or replace that system on module using the one that has this additional connectivity. So that's really, really important and useful, and it's part of the price here. The other part here is what's in that module. It has a microcontroller. This one has a Realtek microcontroller that has Wi-Fi, BLE, interaction with hardware through GPIOs, I2C SPI, all you need, all over there, right? You also have a flash in that module, and you have a modem for cellular connectivity, and it happens so that this very one, the B95M5i Quectel, also supports satellite fallback. So if cellular connectivity is not good or inexistent, the chip will switch to satellite connectivity, giving you an unlimitless, connectivity for your device almost. Another thing that it has is GNSS connectivity, meaning you can have access to that global positioning service that will allow you to have a device that knows where it is all the time. And you will know as well because it's connected all the time to your systems. So that's just to illustrate what system on modules is about. Packs a lot of functionality, and as you'll see in a second, lots of functionality you don't have really to care about. When you're developing a firmware for such a device, you don't have to write the drivers, the BSPs, like the HAL, the hardware abstraction layer. This is provided for you. This is actually coming with an OS. The Particle team called that the device OS, that is reach of interfaces that makes developing for these devices super simple. Let me actually prove it. Let me go to the getting started page, right? When you unbox some of these devices, you get an instruction to go set up your device using that link. So here I've got a Photon 2, right? This is the one coming in this box. Let me move things around here so you can see only it. That's the one we're interested in. Little device, which is a development board, the Photon 2, for testing and working with the P2, the module that is in there, the system on module here that has Wi-Fi, BLE, it has the microcontroller here, and it has connectivity through all these pins here, all the digital pins. It has I2C as well. It has power, like everything you need, and it has a USB connector here for power and for development with your laptop, right? So, or PC or whatever. But the first thing I need to do is to claim that device, make it mine, right? It comes out of the factory with an ID here, which is unique to it. What I want to do is attach that one to my own Particle account and claim it as mine. So this way I can then interact with it from the Particle cloud. And I also can use it locally for development, you'll see. So this device is one with a USB port. So that means that it will be discovered through the web page that I'm on here. So it's not a local tool, it's just a web page once again. I'm going to connect this little guy here. I didn't install any drivers. It's using, the web USB interfaces that's pretty powerful from the browser. It did detect the device. Great. And now it will get it ready for an update. First thing you do, device has stayed in a box for some time, you don't know how long, is to update the firmware. It will take a couple minutes, so we'll just hit update device and we'll wait for it to happen. Okay, so the firmware has been updated, the OS on that device has been updated. What I need to do now is attach it to one of my organization. I only have one, I call like personal sandbox, and that's my toy place in Particle. And then I need to pick a product. You might have different product lines, and so that's why you want to attach this device to your product. Maybe you're working with different customers, integrating for them. I don't know. You mean like this notion of a product within the organization that is practical. So I'm picking the one called My Photon 2. I already had another device that I played around with earlier on, so that was already there. I could have created a new one. I'm going to name my device Olivier Photon 2. I think I like the name that came up. Actually, I typed it earlier on, so that's why. And the next step is going to be configuring the Wi-Fi for the device. It detected the different Wi-Fi networks around. I'm going to try not make any typos here and configure the Wi-Fi on the device. So it's pushing the credentials for my local network and will allow it to be configured for development. And that will be really practical. From there on, I could eventually detach the USB tether here, put it on battery, and have it controlled and developed over Wi-Fi because as you will see, I can do all my development in the cloud and deploy to that device that now has a internet connectivity. As a matter of fact, the next step is to go to my console. So the Particle Cloud Console is where you're going to see all the information you need about your device, about your products, about your organization, right? And here I have a lot of details about my device, this little device here. It has a default firmware, doesn't do anything for now. It's just there alive, connected to the Particle Cloud, declared itself in a secure way, obviously. And now here I have its ID. That's been like, it's on the chip. I don't know anything about it, but I do know its name because that's the way I'm gonna interact with it. Yeah, so last handshake tells you when exactly it connected the last time, was the owner, this kind of things. But that's pretty much it. I have some information about its connectivity, Wi-Fi in that case, and I can force enable over-the-air updates. It has functions. Oh, interesting. The default firmware comes with, and you'll see that, ways to interact with the pins from the cloud directly. I might not do that, but that's interesting. I didn't notice that the default firmware was doing that. Anyways, in the portal here, in the console, what I'm able to do is to write code and deploy to that device. That's the first prototyping proof of concept aspect that I think is really interesting with Particle. Once the device is connected to the Particle Cloud, I can start playing with it. In that case, you can see that I'm opening what they call a sketch. If you're familiar with Arduino development, you'll be at home here. And it's the same notion of sketch. You have a setup function, a loop function. Everything about setting up the hardware and initializing your application happens in the setup, and then it is called once, and then you have a ever working loop function that you will implement. Let me blink an LED. I can do that. It's pretty straightforward. It's one of the samples that is provided. You have other options. We'll look at the web connected LED one after that. Publish, subscribe, tinker, play around. Anyways, so this default LED blinker is working on pretty much all of the Particle boards. Here in my case, the device has, if I switch to that view here, you'll see better. The device has a little LED that is the development board just next to the USB connector, and it's hooked up to the D7 pin. In the example that we have here, we're seeing that we're initializing two LEDs, LED 1 and 2, one on D0, one on D7. I'll just ignore that for now. Just one is enough for me. In the setup, we're setting the GPIO mode to output mode, and we are then in the loop writing the value of that output of that GPIO to high and then to low after a second. And then we just wait a second, and that's going to just loop like that indefinitely. I'm going to select the device I want to target, and that's this Photon 2 here, right? That's the one I'm interested in. I'm going to deselect this one, and I want to develop only for that Photon 2. I have that, we'll see after, a boron and another photon that I've been, using and playing with. I'm just going to use that one. A couple of things it does here. It allows you to indicate which OS I'm having on this device, which will bring the right settings for the compilers. It knows which device, which OS. So from there on, I can just compile the code here in the cloud. I didn't install any tools locally for now, right? And once the code has been verified, I can deploy it. I can flash the device, and then we'll see it running. Here we just should see that little LED next to the USB connector start flashing around. Let's see if it works. So the big one here is about the flashing process and the booting process. And now you can see a little blue LED here that is flashing every second. So pretty straightforward. That first step of creating a little application that is blinking an LED, right? That's the de facto, hello world application for IoT. Let me look at the web connected one. I'm connected to the web, right? We saw that the device here through its OS is able to communicate with the Particle cloud, but I want my application to communicate with the cloud. I want to control that communication here. And here we have a very simple web connected LED example, which is really interesting because one thing I didn't mention before or didn't highlight is that you might have not noticed, but there is no include header, there's nothing library to bring in, but I still was able to use functionality that is made available by the OS, by the device OS through its APIs in my application. So I could set up the pin mode, I could do a digital read or write. It was pretty straightforward. I'm going to do something else now. I want to interact with the Particle cloud. And Particle offers several ways of interacting. In that case, I'm going to use the function which allows a command to be sent from the cloud to the device. The device will declare a functionality that will accept a string as a parameter. And the command itself has a name, a function as a name, and then it will execute something when receiving that command from the cloud. And the only thing I need to do is to call that function during the setup called particle.function. I'm naming it, and then I'm attaching a callback to it. And the callback, you can see below here, it's called LED toggle. And what it's going to do is if the command is on, the text, the string on, I will set the LED to on. If the command is off, I will set the LED to off. Pretty straightforward. I'm still targeting my Photon 2, the right version of the OS. I'm going to flash the application. Okay, so the device has been flashed. It's now running. I'm going to go to my console here. And this is where my device is, right? And from there, what I'll be able to do is I'm going to refresh that list of functions here. And as you can see, here it declared a new function called LED. And when I pass the command on, I'm going to call that. Before that, I'm going to switch to the device itself so you see what's going on, right? I'm going to call that function and boom, it turns on that LED up there. If I type off and I hit call, it's going to turn it off. And back on and back off from the cloud. So pretty interesting and powerful here because I was able to interact with that device from the cloud with one line of code on the device itself. And now, everything happens for me magically almost, right? So that's an interesting application I have here. I could evolve it and I will evolve it. But to do that, what I'm going to do is I'm going to switch to Visual Studio Code to show you how a local development works. So the first thing I want to show you in Visual Studio Code is the extension. I did install the Particle Workbench extension as this one here. Pretty straightforward. It comes with everything you need to develop for the Particle devices. So the extension shows up here. It has a nice landing page where you can log into your Particle accounts, where you can have more information and documentation about all the development process and the workflow, right? I'm going to go through that workflow with you. But the first thing I'm going to do is I'm going to create a new project. It's going to ask me to select a location. So I'm going to pick my demo folder here. I'm going to give it a name. Let's say Particle Test, something like that. Should be fine. Create the folder. And here it gives me a template or a skeleton for an application. There's one CPP file, not an INO file, by the way. So CPP here. And in here, you see we include the particle.h header, which has all the APIs for the device OS. So all the interaction with the hardware, there's a logger, there's like everything like that you would expect from a real-time OS is exposed there. Then you have the setup function and a loop. Lots of explanation in the comments here, practical when it's your first time. And as a matter of fact, I'm just gonna, uncomment these lines here in the sample, which is about sending data every 10 seconds to the Particle cloud. We've seen earlier on how to react to a command from the Particle cloud with a single particle.function call. Here we're doing a particle.publish each time you want to send something. Once again, I'm not telling the Particle OS here, which network connectivity or if there's connectivity or not. Particle, is there. There is a particle.connected information that you can check if the device is connected or not to the Particle cloud before doing something, right? Eventually force the connection. You can also pick different connectivity if need be. In my case, I want to stay agnostic, leave it to device OS to decide what works. And in here we have only Wi-Fi, so that will work perfectly here. So I'm publishing Hello World every 10 seconds to my Particle cloud. But before I can do that, I need to configure the project for my device. So here I have a P2, and it's running device OS 580. It's the Photon 2 platform, and I need to input the name. So let me check. The name I used was Olivier_Photon2. There you go. That way, it will be able to deploy my code to that device. And from there, I can save this file here, and I can say compile application locally. This is going to take maybe 30 seconds, 1 minute to compile the application. It's an iterative process. So here it's bringing libraries that I'm using, so the device OS libraries and so on. It's not compiling the OS itself per se, so not the entire firmware. And that's interesting because when you think about over-the-air updates, you don't want to systematically flash the entire firmware. You might want to only flash your application, right? And so the way you're doing that in development, well, you're going to have the same concepts in production when you're doing an over-the-air update. You will send only your application if the device OS, if the OS itself is not changing, right? So the firmware update is going to be way faster because you don't flash the entire firmware. Compiled successfully. Now I can flash my application to this device, right? And so the behavior I'm expecting is going to be to send data up to the cloud. So nothing will happen on the device itself. Previously, we were controlling that little LED or flashing it. Now we will not do that. What I'm going to do is very simply just looking at the console to see what's going on. So the flashing is in progress. I'm going to switch to the console itself, go look at the view for this little device here. So I want to write device, and here we're waiting for events, right? So device is flashing. You see the green LED going on and on and on. After the flashing, it's booting. So it's booting the device OS, and then it's starting the application. Once the application is on, it will come up here, and every 10 seconds, I should have a little message from the device itself that comes up that says hello world. Let's see if it works. Yay, there you go, hello world. It worked. And we have this information here, which is this device ID, the date, the hour, perfect here. So I was able to send a message to the cloud, to the Arduino, to the Particle cloud here very easily, very fast. It's pretty straightforward. I want to do a little bit more here. I want to show you how I can leverage some Arduino libraries because, as a matter of fact, Particle comes with a full stack of libraries for you to use. I actually will want to point you to them real quick. So if you go back to the console, you look at Web IDE here. In the Web IDE, you can go and search for libraries. And in the libraries themselves, you can see the top ones here. But let's say I want to do work with that sensor that I have here on my table, the BME 280. So that would be this library I will need, right? And so you can do that in the Web IDE here. There's documentation that comes with it. There's examples as well. So if I go and look at this guy, I can see a bunch of information here. So an example here would be, for example, this BME 280 test.ino. And in here, you can see that the idea is to create that object of that type, BME. And then you do a begin. And, you then in the loop want to print values, and the values are read like that. BME.read temperature, read pressure, read altitude. Very interesting, right? Actually, I'm going to eventually steal these couple lines here. They're interesting because I'm going to use them. Okay, I've done that before. Let me go back to my code here. So I need to integrate a new library, right? So I'm first not going to do that anymore. What I'm going to do is I'm going to search for a library. So if I do particle find libraries, I'm going to do a search for BME 280. It's going to use the terminal here to give me the answer, not a website. And the one I'm interested in is this little guy here, the Adafruit BME 280, because that's the sensor I have here. Let me actually bring it down here because I want to connect it to this little guy. So let me disconnect this guy. Let me put the board on the breadboard. There you go. Boom. So I'm connected over the I2C SDA and clock signals, and then I have power, and I have also, my hands are in front, sorry, power and the ground here. So little sensor here, temperature, humidity, altitude, things like that. Really practical. I'm going to reconnect the little guy here to bring it back online. And here I'm going to bring that library, and for that, what I'm going to do is do a install library, and I'm going to put the name, and I'll see in my project a new folder will be created called lib, and in there I have the Adafruit BME 280 folder where we have the source for the library that I'm going to compile into my application, but we also have examples, right? This little examples I was mentioning earlier, the code is all here, so I can definitely copy paste from here. That will be pretty practical, right? So let me go about it. So I'm going to include this Adafruit library. Okay, it's called Adafruit sensors, or BME. I don't recall. I think it's BME 280. Right, that's the one. .h. Perfect. That's what I need. And here I'm going to create the instance that I need. Let me go to find that. Boom, easy. Thank you, Copilot, for helping me there. I'm going to add a couple of things in there. What I need to do is I'm going to locally have these temperature. We'll initialize to 0, humidity, pressure, and altitude. There you go. That works. I also will add a little Boolean here that is called as sensor, and the reason I'm doing that is because I want to test if the BME sensor is detected on I2C, and I want to crash my application if it's not there. I want it to just be there in case I need it, but I don't want to crash it. So here we go. I'm all here in my setup. There's one thing I've not done before, but I want to show you. What I'm going to do here is I'm going to try and call the particle.connected function. If I'm not connected, right, what I'm going to do is, okay, is do the connection, right? So I'm going to force that connection, and I'm going to wait and retry every second until I'm connected. My device needs to be connected to do anything interesting, so I'll do that. Okay. The next step is going to be to initialize my sensor. I'm going to do a BME begin, right? And I will store the result in as sensor. Oh, I'm outside of my setup function here. There you go. That's going to be better. Okay. If not has sensor, if it failed, what I'm going to do here is, just tell it, let's forget about it, right? I'm not going to be too harsh on it. What I'm going to do is just do a log here to say that I don't have the BME sensor, right? So boom, let's check the wiring, check everything. It didn't work. Else, what I'm going to do is I'm going to do better. I'm going to do, hey, I found your sensor, right? And I'm going to use something interesting, which is the variable command. And that one will create in the particle cloud what I would call a device twin or device shadow, something that lists a set of parameters that, or variables in that case, or properties that the device will expose. I will do that for all of the settings: altitude, pressure, humidity, and temperature. Pretty straightforward, right? So now this value, temperature, humidity, pressure, and altitude, will be reflected into the particle cloud as properties or as variables, right? So all good here. Eventually I can send a message to the cloud. Hey, we're good to go. The BME sensor was found. Yeah, well, Copilot sometimes is like, hey, so let's do that. Hello, P2 or Photon 2. There you go. Boom. That's it. And now to the loop function. So now in the loop function, I'm going to test if I have a sensor. I think that's reasonable because that's why I created that one. And in here, what I need to do is I'm going to read temperature, humidity, pressure, and altitude. Eventually, I can log them, right? Eventually, I think I recall if I looked at the test here at the sample, that the temperature or was the pressure had to be divided by 100 in order to give me hectopascals versus just pascals. So that's what I need here. Sorry, I didn't switch the right window here. The pressure will be in that. So here I'll do that, and we should be good here. And the altitude depends on the sea level pressure that is defined up there. Oh, I didn't define that one actually. Good call. Would have crashed. Let me bring this one here. And oh, okay. We have everything related to our BME sensor here. And we should be able to try and compile this guy here. Let's go. Okay, compiled successfully. Let's flash the device. And as I did previously, I'm going to switch to the console for this device here. It's flashing, as you can see up there. And so let me clean that here to remove all the previous events. No variables, no functions, which is that device twin or device shadow aspect of things I was mentioning before, right? We'd used the function before, the LED one, to turn on and off. Let's see, that was an old call here. That was the previous firmware, not the right one. Now it's flashing. Okay. Okay, so here I can see it switched to DFU mode, started the flashing worked. Hello Photon here, Photon 2 here, that was the message at the end of the setup function. And here if I refresh the variables, I see that we have variables that have been declared, and I should be able to get them, right? Nice, okay, that's pretty cool, I like that. Now I see these variables are available in my cloud. One thing eventually, I want to have them as telemetry. If I want to have them as telemetry, eventually more than just logging them locally, and that's something that I would see only on a serial link here. What I want to do is I want to publish this data as telemetry. And what I want to do is I want to publish that as a JSON, right? So let's put a little text here, updated sensors value, like that. And I will put the format in there. So let's do that. The content will be something like that. So string format, and in here I will use that, right? I want to put an open bracket. Where's my open bracket here? And then temperature. Oh, look at that. Temperature, humidity, pressure, and altitude. And here I put all this information, and that's going to be looking like a JSON. Perfect. Okay, perfect. Let me actually compile this again. It should be pretty straightforward and fast. Okay, compiled successfully. I like that. Let me flash this application. Boom. Switch to the console. Clean up the console. Oh, there you go. It's back on. Photon 2 is here, and oh, we have updated sensor information here. And look at that. Now I have my JSON here, right? The raw data is that, right? With our prettify, I have this here, right? And you see the entire thing is like, hey, there's a name for the publish, you know, type of message eventually, and then there's the actual data, the workload, right? So the actual, you know, workload. So that's, oh, payload, sorry, that was the word I was looking for. So that's pretty straightforward. As you can see, you know, I was able to send telemetry, set up a device shadow up there. Last but not least, what I want to do is use the exact same application that's running on that Photon 2 here on this other chip that has a different SOM, another particle one called the boron. This one has cellular connectivity. So this one, I did onboard it onto my particle cloud, and it did set up the SIM, the eSIM that's on there, and the device is connected when I put it on battery, obviously. So what I'm going to do is that I'm going to remove the Photon 2 from this board here. I'm going to replace it with the boron board. There you go. And I'm going to connect this guy to a battery, right? So let me show you real quick. I have my little battery here. If I can zoom out a little, you can see a bit more what's going on here. There you go. So I have this little battery here that you know, has nothing to do with the PC, and I'm going to connect it up there, so the device will be only powered through this little battery here, right? So device is booting with what I think, I don't recall, but I think it's the default firmware on the boron here, right? So device is booting. I'm going to go back to my code. And so Visual Studio Code, where are you? You're here, right? So particle test, the same project. I didn't change it, right? What I'm going to do though, is I'm going to change the device, right? So I could do that using the command, you know, but here what I'm going to do is I'm going to go with the boron as the platform. The device OS in there, because it's on the BSOM. What is it running? Let's see what it is running, actually. Let me go back to my list of devices. Let me go to boron. This little guy is running 610. So that's, you know, the version that I need to select in here. And the name, what is the name of this guy? Olivier boron, right? So that's the one I'm going to use as a name. Boom. There you go. And because I changed everything in there successfully, blah, 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 successfully changed that and that and that. Okay, terminal. Let me close it. Oh, all right. And what I need to do is to recompile the thing for the boron this time, right? So let me go here. Let me compile for the boron, the exact same application once again. I didn't change a line of code, but I changed the target here. And because it's using the same pins, you know, I'm interacting with hardware the same way. This time I'm doing local compile, and then I'm going to do a cloud deploy. Remember, the device is not connected to my laptop over USB. It's actually using cellular connectivity in order to be connected to the internet, right? The little antenna going out here. Compiled successfully. And now if I go back to my command palette, I'm going to say flash, but this time I'm going to pick the cloud flash. So this time it's not going directly from here, it's going from my dev machine, from my IDE, up to the particle cloud, pushing the firmware to that device that is connected over cellular. And that's the exact same code once again, right? So it's flashing, you can see the message here from particle, and you can see the device blipping here. So that's something happening here. I'm going to go back to my particle, you know, put a boron. That's the boron here, right? And boom, I'm already receiving the data from our little friend here. If I refresh this, I can see that I have the latest temperature, humidity, pressure, and I can use APIs to do that, right? And here I have the JSON received. Well, I hope that was interesting for you. I hope you liked this little demo here. If you want to learn more about Particle.io, that's the site. Expect more articles, expect more videos coming up soon, as there's so much more to discover about Particle. So thanks for watching. Don't forget to subscribe, to like, to whatever. See you soon. Bye.